Okay, well, everybody offered first, so let's let Joy show.
Well, I'm sure yours is extremely correct, and mine is incredibly wrong, but.
No, yeah, it's perfect. Yeah.
So I don't know the syntax, but I'm
You can-
trying to post it right now.
Okay. There, I just turned off my screen share. Good enough for the AirPlay. There we go. Sometimes, yeah. I wish we had the freaking remote. Okay, there we go.
Okay, so
That doesn't look like code. That left part looks pretty sad.
it really does. I really don't know. Sorry, I think it's.
It's showing the different desktop, right?
There we go.
Okay.
So I just wrote out what I was attempting to do, and I'm trying to do it.
Okay.
I wrote out that I'm attempting to create, well, the things that I thought I needed to do, create a field, and those would include the integer population, and I thought that it should also be an integer. So trying to create a for loop that iterates over every week, and increase the population at every iteration of weeks until week hits week 5. And then I was trying to return the number of bunnies at the end of the iteration. I'm not sure if that's correct. Is that the correct process?
Your algorithm is correct, yes.
My algorithm. Like the thought here.
Yeah.
Okay. So then how I went about doing that, I don't really know. This is what I did.
Right.
This is other stuff that I attempted to do. So yeah, I defined those variables. I thought that the rate of increase should have been, I don't think that, yeah. That was listed, and then I tried to iterate over those weeks, although I had a for loop, I think I deleted it. And then, yeah, so what part is that?
Okay. So your impulse is a valid impulse, the one that suspects you need to iterate over for each week. That is the right direction you should go into. I think what we need to work on, though, is recognizing when we need to make a method to do our work for us.
Okay.
Right? So we have main here, and you're putting all these local variables here in main. But these aren't fields, keep in mind. These are local variables. The difference is that these are in a method here, and fields are part of classes. So in main, you are setting int population, int week, double rate of increase. Those variables are all acceptable. Okay. And then we do all of our algorithmic work here, lines 28 through 33. And what we should be doing is, in our main class, abstracting all that out into its own function. Okay. Above all these local variables, let's just write a call to Cherokee here. Let's write not the method definition. Let's just call Cherokee here. It's not going to exist yet, so it's going to be red. But let's just pretend like it does and try to call a method. Okay, it's Cherokee here. So what 3 values are we testing for a Cherokee here method call?
We're testing what the population is, what week it is.
Let's pass those sample values into our method. So let's start with the starting population. Now what we need to do here is pass in actual values.
Oh, okay.
Yeah.
The population size is 150.
Correct.
And the week is 0.
Well, hold on, time out. What we need to do, the second parameter according to the problem is the rate of increase.
Rate of increase.
by just 0.1. Okay, so yeah, 0.10, 0.1, same thing, right?
Okay.
And then the third parameter is the number of weeks that we're going to calculate. So like this, in the sample problem, this is 5, right? So Cherokee Hare is going to accept those 3 parameters, right? Hold on. It's going to accept those 3 parameters, and what that method is going to return is a number that represents how many bunnies are going to exist after 5 weeks. So let's wrap that. Thanks. Let's wrap that in a system.out.println so we can see the output of our Cherokee Hare function. Well, I'll probably just put the print line around that we've already written on line 23. But yeah.
So leave the variables there.
What we should do is cut anything related to calculating the Cherokee Hare into our clipboard and out of the main method. So let's cut lines 24 through 38. All right, now let's write a method signature, okay? Let's define a method in our main class, so not inside of our main method here. Yep. Let's define a method that is a public static method that returns an int, is named Cherokee Hare, and accepts an int, a double, and another int. The first int's name can be starting population. The second int, or the double could be rate, right? And then the third is the weeks, which should be an int, correct? Okay. Now let's make sure we include our curly brackets. Yep. Now let's paste all the stuff into here. Not that. Oh no. Just overwrote what was in your clipboard then. Oh wow. I didn't even know that feature existed. That's awesome. Yeah. Should be the second one, right? Yeah, that one. Man, I just learned something new today. Cool. Okay. So we're returning population here on line 41, right? Now, I'm curious about what you're trying to do here with set rate when it's population variable. So integers don't have a method called set rate. So this seems like a stab in the dark. Right?
Yes.
So let's just delete this line. All right. Starting population, we have a rate of increase. Those are being passed into our method. So we don't also need those as local variables. Okay. So we do have we have starting population, rate, and weeks. Those are the variables that are going to be exposed to this method, right? So what we need to do is some math, right? Like we need to take our starting population number and multiply it by 1 plus our rate. Make sure you group it right, because otherwise it'll. You want to do that, and you want to set that equal to starting population, or make a new variable called like population, make it double. So do double population equals starting population 1 times rate. Boom. Okay. So this is something that needs to happen number of weeks times. Okay. We did it once already. We need to do it we need to do it weeks minus 1 times now. This is a little bit of a weird approach. So let's just set At first, what we'll do is just set double population equals starting population. So let's just say our beginning point is going to be the starting population. So just add a semicolon after starting population. Okay. So in our let's replace our while loop with the for loop. Okay. So let's iterate over the for loop weeks number of times, right?
You always have to go int I equals.
Yes. We're going to start I off at 0. Yep. And then we're going to loop while I is less than weeks, right? Since we don't know what the value of weeks is going to be every time we run it.
And then it's length, right?
Nope, actually weeks is a number already, so you can just, yeah. So what we need to do is set population equal to the current population times 1 plus the rate of growth.
Set population.
So
Inside the for loop?
yeah, inside the for loop, we're going to reassign population. And what we need to do is increase it by itself times the population rate.
Itself times the what?
The rate of growth. So the rate of growth is 10%. If the rate is 10%, the rate of growth would be 1.1, which is 10% over 1. Okay?
So that's not okay. I need to change that.
You're going to pass in a 0.1 as the rate, and if you multiply something times 0.1, you're going to get 1/10 of value. If you want to get 10% more of that value, you have to multiply times 1.1. Yeah.
So I need the rate times 1.1.
No, do rate plus 1 in parentheses to make sure that population is multiplied by the rate plus 0.1. So that's 100. Think of it like 110% of your current value, right? Cool. Did you run it? Oh, cast the. Oh no, yeah. Return the population, but cast it as an integer. By casting, we gotta surround that int there with parentheses. Population to make it make more sense. Right. Looks like we maybe have issues that are not
Related to this one?
Yeah.
No, not really. Okay.
You can double click like where you're seeing those issues, like in the error log, and then maybe comment out that code, or delete those files, or you can create an entirely new project.
It's just.
Yeah. I would create it from a template there, make it be a command line. There you go. Yeah. Well, yeah. There. Good. Okay, yeah, let's set that on there. So what? Hold on. What are you doing right now? You don't need a new class. Hold on, just wait. What are you doing?
Sorry. There we go.
Okay, but that other code's still not going to compile, so your project isn't going to compile. Okay.
All right.
Well, now what you can do is just run this guy instead.
Run what guy?
Put the green triangle on line 9, 8. There. 341. That's the right answer.
What says 2?
Sorry, 241. My bad.
Okay. Oh, okay. All right.
It's okay.
Thank you. Thank you, class.
How did you do it, Mike? You want to show your screen? Did you get the right answer? Yes.
That was way faster.
I now realize that I just casted it and returned statement and returned it signature.
Yeah.
Casted it to an answer for you. 5, 6, 7.
Yeah. So this is what I was going to show you. This is a good observation, Mike, is that this is mathematically equivalent to doing current population parts of the week's power. So let's see. You don't need parentheses around percentage increase plus 1, since that's all grouped together in that first argument. So that's a little weird, but not a huge deal.
It took some finagling to finally figure it out. So, parentheses.
Yeah. So yeah, also,
So that means I'm not through it and just cast it.
correct. Yeah.
The method signature.
Yep.
I didn't realize that I could do that in return.
So one thing you gotta watch out for is if you have, so good job, Mike, that's perfectly good. One thing you gotta watch out when you're doing math like this is how you're casting doubles to ints. I know that's one thing that I did at first. Check it out. I basically just so this is the same thing you had, Mike. I reuse population as here. So I was like, as my ints, I'll save it as an int here. So 241 actually got on there. This expected return a double. Right? Or hold on, 150 times 1.1 should return 5, right? So for every time you do that and you assign it to an integer value, you truncate those decimal values. Since I value in the next iteration of my for function has an effect, those decimal points get lost. So over the course of this problem, I lost 2 bunnies. When you cast these primitives between double and int, for instance, that you don't accidentally lose precision and mess up your results. Okay? I just realized I'm projecting myself. So yeah, what you need to do is cast it at the end. Do all of your make sure that you don't have a final number, and then you can take the number. And you know that if your rate is going to breed you like 241.5 bunnies, there's no half bunny in the real world, so it's 241. You cast it to, that's a safe cast to an int. Like if you do a mathematical operation and like you get a fraction, like if you're counting the number of times something is going to happen, it's going to be an integer. On average, it's going to happen like 15.5 times. It's not going to happen 16 times. So the same thing happens here. Also precision with casting. Moral of the story.
I guess I have a question about why you use POW.
Yes.
It's math, it's
Yeah.
power of.
So how are people finding these functions? I know that you can hit the dot and something will pop up, but
That's exactly what it is. So I took math dot and then looked through what came up. Found that's probably power. So I put that and then I command clicked what it took in and what it returned. So I took in first value and raised it to the power of the second value. So I was like, that's exactly what I need. But with lessons and examples.
Good work, Mike. That's exactly how you should go about researching things. So that's awesome to hear. But yeah, so like if you start out with a starting population of 150, and it's going to be 100 times 1.1, second times 1.1 times 1.1, and then so on and so forth until 1.1. So that's 241.5765, and here, and here is the same as 1.1 to the 5th power. As value that is 241 that somehow Google is not giving me. Because incrementally adding or incrementally multiplying times 1.1, you can just pow it. So. Okay, so to a good bit, we have not a lot of time because we have to head over to Skookum at noon. So we're going to zoom through these things real quick. But it's really just an example of the past couple of days. We're going to add a new Spark project. Well, before I get too deep into the lesson, does anyone have any questions about or Java in general? Anything?
I spent like 2 or 3 hours trying to figure out how to post my messages again, because once I had cache map, I had like I had a static cache map, so I could apply it to the create message, post, and the get function. So, that was how I could post it, and then I kept trying to figure it out, and I mean, I had like 7 different commented out, like, I had like things I just tried to like manipulate and tried, and so I after class, like from the user class, so I did user dot messages, I tried to do it like 7 this morning. I asked Mike, and he told me that he had the same problem, and so he showed me how to do it, like in Get. so I could actually access it through the hash map that I had created under get, create messages.
Yes.
And that was just brilliant. So that was only, I struggled with that for like.
Well, it seems like everybody did that same thing. So I think everyone was confused by the fact that there's multiple hash maps. The one hash map that was a field, that was a static field, stored your users. And there were hash maps inside action. Responsibility was to pass data to the template. And those, I know Mike and I talked about this a lot, could not be as a part of a field of the class. They had to be inside, they had to be local variables inside the Lambda expressions.
And I think I was confused because I didn't realize, like, in my get function, that like under would be where you would like. So I didn't realize, like, but then I looked at it again and it's like it was under the if else statement. So if user is no else, and that makes sense because you're getting it and going to the actual message path. That connects the messages. Okay. And that connects the user and the path as well.
I believe so, yeah.
Okay.
So I think what you're down into full responsibilities. Which means it receives data to update the messages for a user and return to the homepage. Okay, that is to show you messages if you're logged in, and if you're not logged in, so try to, in English, break down these different routes, things that they should be doing. I think this becomes a lot clearer. I think it's muddled because there's a few different things going on at once. And I think the whole mechanism isn't quite clear, but if you take a step back and just think of these routes as doing very like specific things and leaving, then I think it becomes much easier to understand.
For the homepage there, it has a single task and it does A, if condition, and B, if you need different.
So our Lambda expression, then it renders the login, or if you logged in, it renders the messages. If you're not logged in, it renders the login time.
Its sole purpose is to just get you to A or to B, depending on.
Well, it would be, what I think of is redirecting to different URLs. And it actually doesn't, the homepage doesn't redirect you anywhere. It doesn't change where you're, it still is the homepage. It's just what the version of your signed in is different than the one than when you're signed out.
Okay, because I understood it different. I understood the way that it's not.
Yeah, well, think of it like Facebook, right? And like .com, when you're not logged in, you're going to see like the Facebook homepage, and it's got like a login box, right? But if you're logged in, you see your timeline, right? Like same URL, different appearance based off of whether or not you're logged in.
Okay.
We're doing the same basic thing here with our sample project.
So it's just changing it. It's not you to a new place.
No, it's the same URL. It's localhost 4567 with no relative path. It's just your homepage. Just what your homepage happens to be when you're not logged in is the login page.
For some reason I was thinking like create message was its own page, page, which is one page, right? Then you have or you have your home page, then you have your login page, then you have your create messages page.
Page is page like you have those URLs exist to receive data, but they don't actually display anything to the end user. So that's why we're redirecting. So like when you have the create message and create user endpoints, right? So we submit the forms and update this and redirect you back to the page. And what you see, you'll see the create message page. Back to you. They're just making changes to the server, like the data on the server, and then taking you back to the home page.
So, me and Jen were talking about something last night.
You call her Jen? That's 3 names now. Jen, Jenny, and Jennifer. Jen? Okay.
I call you Jen. I call it
Whatever. I'm sticking with Jennifer. Okay, continue.
She was wondering about the Spark.delete,
Are you okay?
and so I looked it up and like myself, because like the Spark.delete basically, at least from what I like looked up, was like basically be like deleting a page, right? Or like deleting a URL, right? Be deleting the information on the URL. So what is it?
Well, let's look at it.
Like post is sending information to a page.
Doesn't do it. The Lambda expression does it. Let's look at it.
Like you can buy, like if you're a company and you want to buy like or something, and they offer you 70 pages or whatever in your website. Those pages are different than like this would be one page, right? Going to one page because we never change pages.
Yes. But usually, if it has advanced like functionality, like logging in and logging out, and displaying dynamic stuff, then it's a little bit more than that. It's like not a particularly. Right? I mean, I'm not sure, like Squarespace.
Or like any sort of like Squarespace, like you can create easy like website templates.
Sure. Well, I mean, those are all static, right? I mean, if you hire somebody to build you and they charge you per page that they build, it's usually no real server-side logic. It's just, here's the page at this URL. So it's not quite as cut and dry as number of pages is the amount of money you charge. Because there's also features involved with each page that could cost more money as well.
Charge somebody for this, would we say 3 pages or would we say just 1?
You don't normally, I mean, in my experience, you're going to charge them per page. You estimate. Cheryl Kaufman? The wrong room.
Okay, so you guys spread out 401, 402.
Who are you trying, like, do you know what company you're trying to go to? Abundant Power is across the hallway. Nope. That's really sweet, though. That would have been nice.
Yeah, that's beautiful.
Yeah. Anyways. Okay. Anyway, so normally you estimate features and you bill based off of that estimation. And it's not, and it could be tied, like the time it would take in your estimation might be tied to the number of pages you're building, but it could also be tied to the features that you have to make for each page. So like if you do a 1-page website, things on it, then you have to build them for the amount of effort it took, right? So it's not strictly tied to the number built. It's like, I think it's going to take X number of hours, so I'm going to bill you for that. That's called a fixed price bid. And also, the alternative is the basic bid, where you're like, I want to charge $50 an hour to work on this, and then we'll see where we get after like a week.
So it's almost stupid to like pay for like if you're building a website on like Squarespace or something like that, then it's almost stupid for like 4 pages.
Well, that's their pricing model. Like if they offer a way for you to not have to worry about the actual development of your website, then it could be worth it to you. I mean, it's not stupid. It's just the value that you get for the money that you pay. Right? It's just, and that's a site, that's a server building static web pages. And what we do as web developers is build custom sites for people.
Okay.
So it's a thing. And you can't apply the same rules for pricing for that website contract work.
Okay, that makes sense.
Okay, so Will, the get and post and delete methods on Spark, they indicate we'll do this action. Okay, so this says like online Spark.get. So we're gonna map a get route here. Get page. So when you go to Will's Awesome page, it's that / relative path. So with a get request, it's going to run this guy right here. Will's Awesome webpage.com / login. This will not work. Like this is not handling you going to the login page in a web browser because your web browser is going to initiate a GET request. The verb is GET. It's like, give me the information at the login page. Now, we don't have a concept of the login page. We have a login, but it only accepts post data. And so our form on the home page right now, post information URL. And in the login URL, if only have this render a page, so it's not like a cut and dry, like, and then that's the wrong way, right? What we opted to do was redirect the user back to the home page. So check it out. If we didn't have that URL,
So right now, the function that's right there, all it's doing is sending information to the server.
no, it's server what to do when you get a request like this. So if it's like when you get a request that is a post request on this action. So it's not actually performing the action for you. It's going to be performed however many times someone visits your website and logs in, right?
Okay, yeah,
So that this is just this is an event handler basically.
okay.
So behind the scenes, when you run this post method, it builds a big table. It's MVC stuff, which is another web pattern. We'll talk about route tables, but basically it maps a verb for a request and a path with its action. So it's like when you get a request on this path with this verb, perform this action. And then it just builds that list. And so when it receives a request, it tries to find path and that verb in that table. If it finds it, it runs that action, right? But if it doesn't, then that's a 404.
Skip don't create this table.
You define in this class are added to this route table behind the scenes.
So the verb would either be get or post or whatever.
Correct. And now delete is an example of a verb that you could use when building your web applications. And the semantic value of using a delete over a post is that your intent is to delete whatever lives at that URL.
Whatever that path and action is.
Yeah. So like where delete we've had like .com/users/Ben, right? And you want to delete Ben. You might send a delete request to users Ben.
Okay, yeah, that's basically what I meant when I said like now.
Okay.
It's like a whole URL.
What made me think that you were under the impression that this method actually ran that action.
Oh, yeah.
And this doesn't do, this doesn't actually do this action. It doesn't perform the action. This just maps that verb with that lambda expression as the action. So, yeah. Which action fits the request? And the information the server has is what verb did you use and what URL did you try to hit? Since finds an entry in that table for that verb and that route, it runs whatever action you stored there. And this is how you specify those different actions.
I was looking at this, like, reference page, and the request attributes, they have like a whole list of requests they can make. Question, but what's the difference between like request attributes versus like request, the query response, or query params, excuse me?
From a Spark perspective, and that's something that I actually have. Let's take a look. So request.
Would be like something that's already inherent in Spark, and like request or query params would be something from like the user. But
I think an attribute is an arbitrary key applied to the current request. So it's like if you need to store information to the current request, then you just put it as an attribute of the current request. So like that, we're only looking at one small part that goes into actually serving requests back to a user. You can tie into like Spark.before. Beforehand, and actually this might be a really great example, if you wanted to specify the context user for routes, that would redirect ahead of time. And username in an attribute instead of the in session. So let's like disregarding attributes for a second, because I think that involves submit. Params is information. It is a method that it allows to get to the information that you sent to the web server. So, in a classical web framework sense, is the query string in the URL. So we looked at an example of a query string the other day. It's specified by the question mark at the end of a URL, and everything past that is considered a query string parameter. So that's separated into key value pairs, which are then separated by ampersand. I think that's ampersand. It's the @ sign, not the email address @ It's the and sign, right? So it's like this. That's like TV for failing me yet again. So that's the sign that splits up these key value pairs. So you'll be like, so if you want to go to, for instance, http://website.com/ or question mark. Well, let's do /search page. We could be on the search page right now, and then the query parameter we're passing the search page is pants and is 5, and something else, maybe tags like filters equals clothing. Okay. So that's how you would specify 3 different things in the query string parameter list. But the Spark framework has decided they want to call form submission from our post forms query params as well. I'd like to, and I think we should probably do this maybe after lecture sometime, is look at the actual packets that are sent to a web server when you make a request. We've done a little bit of that, and you can actually analyze. If you open up a web page in Chrome and you hit Command-Alt-J and look at the developer, you click the network tab, you can see the requests that come from your.
And those are the query params.
No. Well, some of the requests that come from your browser could contain query parameters, yes, but it's not every request has query parameters.
And the query params would be after the question mark, separated by the ampersands and key value pairs.
Key in this case should be Q, value would be pants, separated. This is another key P, value is 5, and then filters is a key, clothing is value.
But last night's assignment, this would be Q,
This is just an example of where you would also see query string parameters in a classical sense.
and try to apply that, like, if I would search for the parameters of username and password, and like, is that how it applies?
Well, the way it's more directly applicable is that, so on line 38, we have request.query params login name. But we never really had anything like that in the URL. That's because we posted the login name through our form. Post requests, it's not in the URL like this. But when you have GET requests, the way that you send data, so think about it, like when you post data to a server, you post that data, you have the data, that's called, it's in what's called the request body, okay? The body of the request. When you want to submit information via a GET request or direct the server to do something by giving it information, standard GET requests don't have, there's no upload, you don't upload any data. So the only way that you can tell the server, I want a specific piece of information, is by passing it through the URL that you have with a GET request. If I want to go to not just the search page, of the search page, my only option in most cases is to make a new GET request to $p=2. Submit a post request to go to that page. That's not how search pages normally work.
So I can do the search query strings and get.
Yes, which is in the URL bar.
This is a question about the developer terminal, like the console log.
Yep.
So is Command Alt J the same thing as just inspect, or do you get different?
That is the same.
Okay.
Inspect just drops you into the Elements tab of the developer console. Whereas Command Alt J, I think, just drops you into the console, which is how you can run scripts. Right? Apple TV is being a real big butthead today, so I apologize for that. Okay. So let's kind of begin. We got a few things to talk about today. Most of it is actually just logical extensions of our previous work. We're going to build some more Spark-based web pages. But I also want to talk a little bit about some documentation on the Spark website, because it's not something we really cover. So here we have how you initialize a Spark server, about verbs and paths and callbacks. Callbacks is like, a callback, by the way, is how you define an event handler. A callback is synonymous with an event handler. It's a method that gets run, that gets called when you perform an action. Server actions are requests at paths and verbs, okay? So valid verbs in this case, get, post, put, delete options. The thing that I wanted to point out to you, though, is that this. We've touched on this before, but I want to make sure that I explicitly mention what this is doing. So you'll see here you have /hello/:name, right? So that doesn't mean that you have a URL at /hello/:name. URL that's just :name. What that means is that it expects a value at that position in the URL, and then when it gets passed into your callback, it's going to have the value name. So you see request.params name. So if we want to actually put this inside of our app right now, we can kind of see what's going to go on here. So we say /hello/name. This doesn't work because I don't have a static import yet, but it will work. Host 4567 homepage. If I do a hello, 404. It doesn't go page. Hello Ben though, it says hello Ben. Right? And then hello Mike says hello Mike. Hello Lindsay says hello Lindsay. Hello Avery says hello Avery. So on and so forth. So we didn't have to specifically map each one of those URLs. We're like, website is users, or it's hello in this case, and then whatever name you pass in.
And any, like Avery's not stored right now. It's just something we typed into the URL, right?
Well, it's not stored, which means, where would you expect it to be stored? Like,
It means it's temporary. So like, it's not, like if I was a user, unless I typed like -Avery, like I would just see hello, right? Because we don't have that in our code, right? Like as of like, just hello -name if we don't store the name.
yeah, so this, I think that you're on the right path, is that this data here only exists,
Yes.
like, it's not stored in session, it's not in a cookie that you have in memory somewhere in your database or in your server somewhere. It's just the value you pass in through the URL reflected back to you.
Yeah.
Be like, hello, blah, 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 right? Or hello, but you know, if I have another slash, it'll be a 404, because these are like URL segments. So it considers this, like here's one part of the URL and here's the second part of the URL. So this is a 404 because we told it what to expect here and call it name, but we don't have a mapping for when we have another slash here. So these forward slashes are kind of like special with URLs. It determines URL groupings, if you will. Okay?
So those are sort of like the parameters then. So like if you had a slash, that would be like a new parameter for, like since we don't have anything, we have name, like name, and then we had password, for example. Then if we put slash blah, 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 slash blah, 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 then like, because we have name and password. So however many, like, sorry, am I not explaining?
I'm trying to think about, because you might be right or you might be wrong, but I can't,
So return hello plus request params name,
Mhm.
and then you could do request params password, except the second slash.
yes, you have to update your URL here to be not just hello name, but like password. But normally you wouldn't want to passwords in a URL like that.
Right,
That's
no.
like a weird practice, but like,
Like close pants.
yeah. So request up params, password.
So they're separated by the slashes.
Yes. So I'm gonna rerun this. So this route has been changed to say hello name and then password. They're gonna get the param password and then just return that. Sorry? Yeah. It's an everyday thing, man.
Like I was thinking this could have been helpful like yesterday in testing, because like if something didn't show up, like I could have like tested to see if it was like included it in your parameter. So like
Weren't really. The data we were sending to the server was really like post data.
okay.
Like what you're really specifying here with this params list is if you want to support like, you know, the site that is going to render like a random arbitrary user. Like you could say, for instance, take that parameter and then look up that user in your hash map and say if that user exists, then display that user information. But if not, then say user doesn't exist.
So you could do that.
Yeah. Yeah, that's the crux of like basically how the entire internet works. Let's try this one more time. AirPlay has got so much potential to be the most useful ever, and then every time I try to use it, it's like, and it confuses me because again, we use this same technology across all other campuses, so it's got to be something specific to us. So I would like for you guys to follow along. I can't share my screen right now, currently, apparently. Oh, here we go. It's starting to work. All right. I think it would be a good lesson for you anyway to open up the today's lesson. It should be current on TIO because we're going to be doing some more framework stuff like Spark app development. So it's good to just get practice with that and make that really as fluid as possible. It's calling me nonstop this morning. I don't even understand what's going on. All right. So a few weeks ago, maybe last week, we developed this console-based application that was like forum posts. If you remember, we did an in-class assignment, like read and wrote to files and stuff like that. We're going to kind of emulate that same thing website. Okay. So we're going to create a new project called Forum Web. I'm going to do that here. Web, so code August 16 Forum Web, good. So, disconnect. We're going to include the things we always include when we do Spark-based stuff. We'll open up our project structure, and we'll go to libraries, and we'll add from the Maven repository the Spark stuff. Pretty old hat now, right? Is that how you say that, old hat? Several times, and it's nothing new. Okay, so I got Spark Core, and I also want to include Spark Template Mustache 2.3. So I checked this box here because I want to be able to look at the source. I don't want to have to decompile it from the bytecode. Because if you don't download the sources and you want to look at like what a method does, it doesn't have all the nifty comments and stuff. Because when you compile your code, it doesn't. Compiler will strip all of your comments because it's not necessary. See the source code. You have to download the sources for the project as well. So we also need a resources folder, resources templates folder to store our templates. This again, something we've done several times at this point. So we have modules, sources. We're going to make a new folder called resources, call it resources, and then mark it as a resources folder, and then I'm going to make a new folder inside that called templates. Okay, there for all of its stuff. So in our forum, we want to store these things called messages, and messages have IDs, they have reply IDs, and they have an author, and they have a text value. So an ID is a unique identifier for, man, it's laggy as crap. I'm actually looking at the message class right now. So I encourage you, like, very highly to follow along on your laptops because I apparently cannot rely on the TV currently. So this public class message ID is a unique identifier. When we get into database stuff, which is going to happen next week, unique identifiers play a very huge role in database development. So every row in a database has what's called an ID. Okay, it's no other entry has that ID in the database. So we're going to get started kind of talking about IDs with this forum web post thing. So a message has an ID. It has also a reply ID. So reply ID is going to be the ID of the message you're replying to. It's not a reply to any of the message. That value is going to be -1. Okay.
So that, Can you say that again?
So each message has an ID and a reply ID. There's a reference to the ID of the message that you're replying to.
And if they're, what's the negative one part?
If this message is like, I'll finally get to this class. If the message isn't replying to another message, if it's just an original message, then reply ID is -1, which indicates there's no, we're not replying to anybody. Okay. So I'm going to take this message class and copy it. Make a message class inside IntelliJ. So the Apple TV should show you me doing that in probably like 5 or 10 minutes.
I know, you can go back to it, so I just wanted to. Yeah, thank you.
Keep in mind, a lot of this, even though we're not able to predict it currently, or this is all gonna, it's all being recorded. So you can go back and look at it. So concept in our forum web of user. So it only has one field, and that's name. So each user just has one thing, its name currently. Make a user class, and I'm going to paste the code in there. Say a field name and a constructor for user. Okay. So if we open up our main class here, create a hash map. Instead of storing our array list inside the user class like we did before, we'll create a separate array list message that stores everyone's messages. Okay. This is more appropriate for a forum since messages from various users are often displayed on the same page. Okay, so we have 2 fields. We have our users, we have our messages. Hey, caught up. So now is add a couple methods to insert test data into our structure so we can continuously test the app without manually inserting information. So let's have these 2 static methods, add test users and add test messages here. So in main, when the app first boots, just add test users and add test messages. So at first, we're going to just add Alice, Bob, and Charlie. Right? These are all our current users. Alice is a new user, Alice. Bob is a new user, Bob, and Charlie is a new user, Charlie. And then afterwards, in our message, we have our message constructor, which the author is the name of a user. So we have ID is 0. Notice how these are auto-incrementing. It's weird that we're doing that manually, but normally when you build like a new object, specified by like some static int that you continuously increase every time you call a constructor. So these 2 messages are not replying to anybody. This message is replying to this guy, Alice cool thread. Its ID of this message is 2. And then Alice is then responding to this ID by saying thanks. Right? See how that works? So each message has an ID, can reply to another message. So you have to store the ID of that message there, the reply ID, right? So that's what we're doing there.
The second one, the Y one is the reply.
Yes, the second parameter to the message constructor, -1, -1, 0, and 2 respectively for each of those lines. -1, it means that this is not replying to any other message. In all other cases, it represents the ID of the message that you're replying to. So the first two, Alice and Bob, those are original threads. The third message there from Charlie is talking to the first thread, like it's replying to the first thread. And then that last message is replying to the thread with ID 2, which is the third one. Yeah. Man. One of my children took my phone charger out of my backpack.
Yeah.
I have an iPhone.
You want, okay, I have one. There you go.
Thanks, appreciate it.
Yeah.
Been in ever since I had to borrow Will's the other day, and then today, just it's not on my patch anymore. Cool. So, next, start working on our homepage. So we're going to list the author of each message and the text of that message. So let's just copy this right here and make our home folder. So go to resources, templates, new HTML file, call it home, and paste. Keep in mind, we kept this doc type. I know a lot of you guys actually ditched this doc type. That's technically not a valid HTML document if you remove that. So don't forget to keep that there.
But you don't need the stuff that comes standard with it, like a couple lines underneath that.
That's good practice to have all that, right, like title and everything, so that people know what you're referencing.
You're referring to the title, which is an element in the head of an HTML document, which will show up in the browser window at the top of it. That's the purpose the title serves. So what were you saying?
When you paste it over, you paste it over like.
This is the,
So that crap we don't need.
not necessarily, no. So this whole part of the document, the head, describes basically metadata about the current page, and is where you would put asset loading stuff like CSS and JavaScript references in some cases. You also include things like the title, which describes the current page, thus the metadata, and it sets the current char set for the current page, which you don't normally have to do because it's implied by the request normally. This is also something that's not common. You can remove that. So if you just remove those things, you get essentially what we had before.
What's not common in that page?
But the lang equals n attribute. Those are not really necessary.
So, okay, so we can do everything except for.
Yeah,
Okay.
So you could create like an
Well-
HTML in Chinese, right? So
you could, but 95% of the time, the page will infer the type based off of so the Chrome is going to be like the Chinese version of Chrome, or the default language would be Chinese version of the website.
You said you could delete everything except doc type. We can delete that too, right?
The doc type cannot be deleted.
Okay.
The things that have to be in an HTML document are doc type and the body element. Body, but then it wouldn't look like anything. It's optional. Okay? So what we need to do now is map the slash route to the action that will render that home page. With Apple TV, we're updating. What you would see is that slash route. I copied and pasted it into IntelliJ. So if you want to follow along, that's where we are right now. On line 23 of my code, so we're making a new hash map. A list of messages called threads. So for each message, if the reply ID is -1, then we understand that that's a new thread. That's a unique thread. So if you think of like a forum post, the threads begin with an initial message, right? And so if you reply to a message, you're not creating a new thread to an existing thread, right? So if we want to display all the unique threads, we get all of the messages where the reply ID is -1. And then we're going to put that into a model that we're then passing into the model and view object. Okay? So if we run this right now, what we'll see is a page that displays the top level threads in our test data. Hello world, and then this is another thread. I'm sorry that Apple TV is not behaving today. I think it gets confused sometimes. You have to be gentle with it. Like, I'm pretty sure if I restart my computer, everything will work, but then I'll have to like restart everything else.
Do you mind repeating what you just said? Because I was looking up to see what was the new thread.
What I said was, I said lots of things.
So what's the new thread? The last sentence that you said.
Just that if the message has a reply ID of -1, then that's a new thread. -1, then that's an existing thread. Okay, so what we're going to do is we're going to print out the top level threads. Okay, so if I'm writing a message and I don't reply to anyone, that's a new thread that I'm writing. These are replies, right?
When I run mine, why is there a link? It's like a hyperlink.
I would check your HTML.
What part of it? I've got, besides text, I've got /ABR. I mean, I haven't pasted it.
You have ABR.
/A. And at the end, I've got /ABR.
Yeah, that an A element is how you specify an anchor element. An anchor is a hyperlink. That's there. Okay, so I'm rendering this page and I'm seeing Alex, hello world, and Bob. This is another thread. So these are two distinct threads. Okay. So what we want to do next, only receive a query parameter for the reply ID so we don't have to hard code it. This block here. And again, you'll have to follow along through the lesson if you kind of really want to see what's happening here.
But you have the A there, so why?
I don't have an anchor. Lesson, there is no A element. We're on the one that it's like halfway down the page, and it says this should be enough to see the top level messages, i.e. the ones with the reply ID of -1. Now let's modify the code to optionally receive a query parameter for the reply ID so we don't have to hard code it. By default, if we don't specify our reply ID, we're going to just look at our top level messages, right?
And you drop down your dots there real quick.
I can't.
Oh.
I've actually been doing way more things than that, but it's not showing up anything. So I'll go ahead and just leave it alone for a little bit with the hope that everything actually responded immediately. So, okay, so works for now. So we copied this text into here. It was we're saying, hey, query parameters, let's try and get the key reply ID and give me its value. Reply ID num, which is set false. Parameter contain is not equal to null. Update the num to value of the reply ID field. be a number that we're passing in through the URL to an integer, and then of -1. So this M has kind of been a convention so far in our class of model that we're passing into template. And also this threads list here, threads for this, right? So it says, if for every one of the messages in our messages field, if the reply ID of that message is equal to the one we're currently trying to look at from our URL, then add it to the local threads object. Today, we're going to put that threads object inside of model, and then we're going to return that model. It will show us all the messages that were sent as a reply to the reply ID message. You click on the message. There's no clickable anything yet. Are you like ahead?
I don't know, I guess I am. But
We'll do that in a sec. So right now, sorry.
So the threads add message, as any message that's a reply to that.
We're trying to filter out all the ones that are not replies to the current thread. So if we look at the ones that we currently have, by default, we refresh this. This says localhost 4567, and this is -1 is the default one. If we specify 0, we should see one message that responded to this, which is say cool. Let's just say Charlie : cool thread Alice. So let's specify a reply ID. Right. So this was the message. These are all the messages that had the reply. Right.
So you're populating the expression that was messages called threads
Mhm.
with everything that has.
100% correct.
I'm asking about when you go to reply, when you go to /5=0, where in this code?
Go to /reply ID = 0. It's a
So it's not,
Okay. You sure?
yes.
Okay. So if you're looking about where we get the reply ID, right now it's on line 23. Give me the reply ID key from the request. Okay. So we can see it works as anticipated. So that's good. So question mark reply ID = 0, we should see Charlie's reply to Alice. This is where you must be, Will, is let's modify the HTML to make the message link 2 replies to that message.
So, question now is how does all that
Mustache. You'll see here that this href goes to the home page, applies a query string parameter. String parameter key is reply ID. Remember that if we go to that URL reply ID = number, we'll see all the messages for that. So let's take the reply ID for instance. So just the /URL, then this is going to give us all messages with reply ID -1. This message, this hello world message to our main one, it has an ID of 0, identifies this message. okay? The replies to this message, we have to go to question mark reply ID equals 0. Here, right? So this,
So that in the Spark get that requests query parameters for ID is that.
oh, well, in the URL is this. It's this. Oh God. It's this.
And the ID number equals integer value.
So request type query parameter is going to, that method is going to look for a query parameter called reply ID, and it's going to have a value of whatever that gets back. And that's going to be a string when you first get it from a query parameters method, and you have to convert it to an int to use way. Okay. Message has an ID. If we want to see all messages linked or we link to it like this. We pass in that current message's ID. We can say this, and I was going to reply ID equals 0. And we go to what the messages that replied to Charlie, and no one's, oh, and Alice replied to Charlie.
It redirects to the second whatever it is, which is reply.
Well, like when you click a link on any page, it takes you to whatever that link says, right? As every time we render this page is, give me this current page, but with equal to my message, my current message. Okay.
The part that, not in the Java that says, give me back my message. Is that the, if message dot reply ID line equals reply ID number?
Yes.
Okay.
ID num by default is set to -1. We see that on line 24. And optionally, our web page can accept a reply ID query string parameter to override that -1 with a ID of a message. Our goal is to get all of the messages that have replied to that message.
Would you create one of those for each message? So like here, we just have the same for
-1 is just
the reply ID.
a special number that indicates these are top level messages.
You wanted to look for, would you do that in the same code, or would you do that, or?
Well, what you're talking about is looking like 0 is the ID of the message, first message.
Right. Like, let's say Charlie. Like, we want Alice, Bob, and Charlie's. So we want to look for both of those.
Right now, we're only supporting looking at the responses to the current message.
Okay.
So if I'm a message, so say I'm this first message with ID of 0, a text hello world and author Alice, okay? Right to this message, right? So I'm message 0 to nobody, so my reply ID is -1. And here on line 52, we have Charlie ringing in. He's like, I am message 2 to message 0. And we know message 0 is Alice's original message.
Okay, okay.
So when we go to the home page and we give it a query string parameter called reply ID, and we say 0 message, show me all the replies to that message.
So for Alice's message, show me all the replies, and it would show Charlie.
And then that page would show all the messages that replied to this message.
Alex.
Yeah, that last one there. Yep.
It just goes to 3 and so on.
I'm sorry?
And then when you click that, it goes to 3 and so on and so forth. If there wasn't.
If you want to respond to this message, do this. You do 4, 3, Bob.
You know, I'm showing all the replies to that ID.
Yes.
So let's say that Alice responded to her own message, not to Cleve. So it would be 4-0. Okay.
If she responded to her original message.
Yes.
Yeah.
Or 2, which you responded to things.
Right. And then here has his own message and nobody's responded to it.
But
Is there any way to show how to show no messages? I think I just heard you say that it shows every previous, right? Did you say that or did you hear?
I think we might have a misunderstanding.
So it's going to show Alice's message because that's the ID, right? And it's only going to show Alice's.
The page is
Not all of them.
through all the messages.
Gotcha, okay.
Yeah, it's going to show us that replied to the message ID -1, which is the default for like no.
So Charlie's ID is 2. He's the second
No. Charlie's message
is 2.
is 2.
Even though Bob has it, like, he's not directly related to Alice's message, right?
Yes, that's correct.
So,
Well, he's on line 54. Bob is replying to Alice's message.
he is.
Relationship there, and then Bob is replying to Alice.
Charlie's reply ID,
Oh,
ID is 2, so if you want to reply to that,
why is Bob 1 if he has nothing to do with Alice's message? So, like, why isn't Charlie 1?
You make a new message, it has a distinct ID. 1, 2, 3, 4. If we were to make a 5th, the ID would be 5. So each message has its own ID.
Even though they're separate, like, because Bob's not with Alice's. and
Correct.
Charlie.
That does contextual awareness of that message. It's just, I'm a message, I have an ID, it needs to be different than anyone else's.
Okay.
And then the second parameter is, who am I responding to? If it's -1, I'm not responding to anybody. If it's any other number, message I'm responding to.
So, like, we could have 5, -1 Steve.
Posting all by himself.
Okay.
Just random threads about nonsense.
Well, what happens if it is null? Like, how would you get that reply ID is not null? What would happen if it is?
Well, according to lambda expression, if lambda is null, then ID num will not be set to this value. And that before this was set was -1. So that's the default value. It defaults and that shows you the top level threads in the form.
So that's about 15 IDs, and they were all, when you apply to 2 pages, there would be 15 messages.
Yes. Leave here around like maybe quarter till noon. The Space Volcano tours take place from 12 to 1. So we have roughly a half hour to get through the rest of the lecture today. Forgive me if I seem like I'm going at it really fast. Some ground to cover here.
There we go.
So what we're going to do is we're going to add like we had before our previous project. Add a spark.post. Post doesn't this things. It just sets up the route table so that when you hit this URL, Lambda is going to do. It's going to look in the query parameters, in which case this is the form post submission login name. It's just the form field, like the input field. So if there is no username, then otherwise, we're going to try and get a current user from at that username. If there is no user in the hash map at the specified username, we're going to make a new user object and then put it in our hash map at that username. Exists. We've done this a couple of times before. So request.session equals session equals request.session. We're getting a reference to the current session. We're storing the username that we just logged into as the username back to the home page. Okay. So then we're going to modify the get route to insert the username into the template or null if not logged in. So let's check out this get route here. Update get slash to say this. Yeah. Bad. Adding to this get lambda a reference to the current session, and we're getting the username out of it, and then we're going to pass that username into our template, our home.html template. We're going to modify our HTML to conditionally display the login form or a welcome message depending on whether the username is null. Update our
So right there where it says reply any feature, offering text, you could list anything that with a message, like any
yeah.
on messages. Right?
Yeah.
Okay.
Remember that in the mustache templating language, any block, this caret here, will show up if this doesn't exist in your hash map. Right? Yeah. Not null, for instance. So this is null. It's going to be falsy, and it's not going to display. It's going to display this block. So otherwise, if username is not null and has a value, we're going to welcome the user. So we're going to logged in. We're going to display the messages list, and this is the same as what we had before. Each message is going to display its ID in the href, and then the author and text of the reply. Finally, what we're going to have is a logout button. So we have this, let's say, but it is just have a username, we want to welcome them and offer them the opportunity to log out. So you see with this logout form, we have a action, which is /logout. The form is going to post to, and the method is post. And we have a button, and it's going to say log out. Route that we're supposed to, but we don't yet have a way to handle that on the server, so we need to make that mapping. Post, log out. Underneath login, just because it makes sense there. to log out, what we're going to do is from a request, we're going to invalidate the session and redirect back to the home page. Okay. We run this. Log in as Alice. And then just these guys right here. Okay. Let me log out again, and it optionally shows that. So you see, that's how our mustache templating engine does stuff. It's kind of enlightening when you finally see, like, you think of these major systems at play on websites, and you're like, oh, that must be some crazy thing that I can't understand, and you realize it's like, if user exists, then display login form. Okay. Underwhelming. In other ways, it is like really powerful. Okay. So, talk about as kind of a review for this week. Woohoo! Never click on that next thing, so I never saw that party thing.
Yeah.
It's really joyous.
Yeah.
So, talk about briefly, and we can go into more detail if you guys are interested over the course of the class, and also layers of the internet. So if we talk about the internet, to be split up into different sets of concerns, right? So when we are making requests to web servers, we don't ever have to worry about, well, we do since our wireless internet sucks. We don't have to worry about the connection, right? About like how the data gets sent from point A to point B. All we're saying is, I want to go there to get my data, and the data is like, it gets back to you magically. And we don't ever have to concern ourselves with the process of what it takes to get from point A to point B. But what has to happen is actually pretty freaking ridiculous, okay? So right now, we have our bodies from like probably 17 different wireless networks concurrently. And that's just what's in this current building, right? And when the data gets back and forth from us, like through us and our computers back to the router, that router is connected, hardwired to an Ethernet, connected to some optical fiber line, which runs all across the hub, which can transfer information all across, like, more than likely that optical fiber is going to go to Atlanta, and then it's going to go to, then over to Los Angeles or San Francisco, okay? Where the server is and the physical location of that server, but your computer has to communicate with it within 60 milliseconds, or you have like a lot of delays. It happens in the blink of an eye. And it's not just across the nation. Like sometimes you visit websites whose servers live in Poland. Once, it was Hawaiian Airlines was my client, and we had to VPN into their network, and their TFS server was in Chicago, Hawaii. So every time I had to check out a file from source control, request to Hawaii, and that would make a request all the way to Chicago, and that the reply would come back from Chicago, back to Hawaii, back to me in North Carolina. There are very complicated routing algorithms. I think we may have, no, that was last cohort. Traveling salesman problems and stuff like that. There's a pretty big branch of computer science that, given a network of nodes, how to determine the most efficient path point B. It's a really deep subject. But basically, the gist of it is you don't have to, because of what's called the OSI layers. So if you Google OSI layers, you'll see different specifications for different layers of the internet. So the lowest layer is the physical layer. We have wireless and electrical and fiber optic lines that actually carry the data from point A to point B, okay? And then above that, internet layer. So from the internet layer, if you're writing a program that interacts with you, you don't have to worry about how you're getting the data from a physical standpoint from point A to point B of the OSI layer, okay? So on top of the IP protocol, we have the transport layers, and transport are UDP and TCP. UDP stands for a Unified Datagram Protocol. It is so receive video from a server, it's through a UDP connection. A UDP connection doesn't give a crap. So there's actually, this all happens under the covers and you never see it. If a website through TCP, there's actually a very complicated validation mechanism. Because if you transfer data between me and like China, throughout the course of that request, it's possible for the information to get lost. So there's a data retrieval process that happens between me and the server that I'm trying to talk to. TCP protocols. So it's like, this piece of information, can you resend it, basically? And it resends it. And then also, not just that, depending on the route each one of your packets takes, they could come in different orders. So when you make a request, you could think of it like you make a request and you receive one big piece of data ever. What you're really getting is 19 or 20, and that's arbitrary. It's split up in a bunch of little pieces, and the server will send those back as individual packets. Okay, so when it sends those out as individual packets, they each decide for themselves what route to take to get to the computer. At arbitrary order, we could get packet 2 first, then packet 3, and then packet 1 and 6, and then 5 and 19, and then 11 and 12, right? For your browser displays that web page. So the time it takes, between you making a request and seeing a web page happening, it's going to receive all those individual packets. If it detects that it lost a packet in transfer somehow, it's going to re-request that from the server, right, and validate its existence. And then it's going to reorder those packets and then combine them together and then web page. It's nuts. Okay. And at the top of that is this application layer. So the application layer is what we work with. We're fortunate enough to not ever have to worry about any of these other layers and just say, I want to make a web page, and the browser and the TCP protocol takes care of everything else. Okay? It's pretty incredible. All right? So we have these things called ASCII and UTF-8, topics of discussion. Hypertext Transfer Protocol is HTTP. You see that's the protocol that begins every website we talk to or we look at today, right? HTTP is you transfer HTML packets across the network, basically. It does the same basic thing as TCP, but on a higher level. So UTF-8, I don't know if you guys ever heard of it, but UTF-8 is an implementation of Unicode with 8-bit words. Just usually your page, like if you see characters, it's in UTF-8. Okay. And ASCII is like an old school version of like before it was the thing. So for now, not super like, or if you don't know what UTF-8 is or anything about the whole datagram stuff I just mentioned, just get it. There's a general idea that like when you make a request to a web page, it's not just like, oh, here's your data, right? It's like process. It involves a lot of the same principles that you see in object-oriented programming. Principle in the OSI layer. Thing that you would see in a well-architected program where you want to do your job and you want to use the lower layer, but you don't want to know any of the implementation details of how the lower layer did its job. You just want to use it to do your job. So as an application writer, I don't care necessarily how TCP is giving me my packets or how HTTP is. I just care that I have a website I want to deliver to the end user. I know that it's using HTTP, and then HTTP doesn't care how TCP is working. And TCP doesn't care about how IP addresses work, and they don't care how the physical wires work. And I just realized we skipped a layer, the internet layer. The network has an IP address. I mean, you guys have heard of IP addresses before. IP addresses typically are a series of values, like 255, so it's 127.0.0.1. So it's like there's 4 different chunks to a normal IPv4 IP address. And each chunk is a number from 0 to 255. And between all those numbers, it uniquely identifies your laptop on the network that it's currently on. Okay? And it gets way more complicated than that, but you can think of an IP address as like a mailing address for your computer, like a mailing address for your home, IP address for your computer. Now, the problem with IPv4 is that it's not big enough, and that so many computers are on the internet nowadays that they ran out of addressable spaces. In many different ways, but they finally realized that there's no, it's just not viable for the long term. So they implemented IPv6, which is a protocol that has space for like hundreds of trillions of. We're never going to run out of space in IPv6, unless we colonize 17 planets and become a population of 14 people. Okay. So that's not necessarily related to what it gives you a broader context of web application development. Keep that in mind as we put in mind. So if you'll notice that in our forum web, we didn't actually have the ability for the current user to make a post. We just saw posts. Okay. So what we're going to do is add that functionality. Homepage, each form name, we don't want to just have the logout form. We also want to have a create message form. If you see here, we added a form down here. So form action is create message. The method is post. Yes. Okay. So since we have a new reference to a URL in our form, we need to add the associated mapping in our main.java file. So let's do that. Message here. So we want to run session because if you try to post something without a valid session, you don't want to be. You don't want people who don't have valid users to post. Local variable text is equal to the message text we passed in. And there we know that we don't have what we need to build a text. If we're here, we know that we are message object to our messages list. Constructor takes in a messages.size, which is the ID. That's just a simple way of generating the ID. -1 is the reply ID, and then the author is username, and the text is whatever we passed in. Session and text came from our query parameters. So after we post that message to our messages hash map, we redirect back to the home page, which displays them. So like this paragraph says, that this works, but it only allows us to post top-level messages. It would be better if it was marked as a reply to whichever post we're currently looking at. So we could do this by page's reply ID to the template. So if we when we render our home, if we add the ID of our current requests, we can get to a. So let's go back to our home page here, and let's add the to our request, or to our template. So we can update the markup to have what's called a hidden input field, which is the value of the reply ID. This is one option for accomplishing this goal. The create message is going to have a hidden input field, a form of data, but this text is hidden from the end user. So it's data that we want to be able to submit as a part of our form, but we don't want people to be able to touch it. We just want to like say this is data we need to have as a part of our submission process. So like if you have an analytics campaign where you wanted to track people that came in through a certain campaign, you value it. It's like I came in through Google or whatever. But there's many ways in which having hidden fields actually helps you. So in this case, we have a hidden field. So this is data that's going to be sent back to the server when you submit this form with this name. And it's going to have reply ID. The current reply form. Okay. So finally, we can modify our post route to use this instead of hard coding -1 as the reply ID. So here in this create message, let's take this text here, go back to main, and then create message, update this. So here on. So we're going to give our form. So string text equals request at query parameters message is request at query parameters reply ID, right? We're getting that from the form value reply ID. Bam, right here. If we specify in our template, we post this data back to our web server when we make a new message. Effectively, what we can do is reply to that message. So before we had, when we made a new message, reply ID was -1. We were hard coding that -1 value. But now, since we're posting that reply ID to the server, when we make a new message, we can just say the ID is messages outside the reply ID is reply ID. Okay? The username and the text are the same, like the author and text and the message are the same. And after we add to our message, just like before, we redirect back to the home page, which should then display all the. So it says currently it always redirects you back to the top level of the forum site. So if you think of a forum, if you're in a thread and you respond to the thread, it shouldn't just take you all the way back to the home page. It should maybe refresh to show the message you just posted. So what we're going to do is instead of requesting a redirect slash, what we'll do is redirect to what's called a referrer. There's got to be a better way to do this. Yeah, no. As you navigate around the internet, on Google.com and you click on like CNN.com from your Google results list, on the CNN.com page, it's going to say my referrer was Google. It's going to be the URL you were when you get here. One thing, like all browsers store a reference to who referred me. As like if you hit the back button, that's the refer of the current page that you're on. Google for CNN, I click the CNN link, the referrer for the CNN website is going to be Google. And the referrer for Google, since I just navigated to there, is not going to be anything because I navigated to it, right? When you click a link, after you navigate, it sets the refer to that field. Okay? So let's run our code. 7. I'm going to log in. And my message. So if I want to post a message here, the reply ID by -1 said, okay. There was no message here. For Z, right? So if not equal to null, we're going to do otherwise is a turn operator.
Zoom in.
Yeah. So to fix this guy, see what happened here is I tried to refer. Refer was null because I just navigated to that page, and then so I'm doing this. I'm saying I'm gonna save a reference to the refer, and if it's not null, then we'll go. If it is null, then we're gonna just go back to the home page.
And why did you do headers?
Because the refer is stored in the header of the request. So check it out. If we go back here to this guy, actually, let's go to Google. Google.com, and we'll type in, and we'll click this guy. We'll go to our network pane and the website. So this is how many requests are happening on CNN.com. Frames, also just I'm looking for.
There's a level 1. That's like one thing.
This one web page.
Yeah.
I went to CNN.com, spawned, goes to find some Twitter stuff. This is the fave icon for Twitter or for CNN. This XHR stands for like an AJAX request. This gets probably like you can see get forecaster. So this is leading me a weather forecast data that's going to populate some weather control on the current page, right? Yeah, it's pretty. It gets pretty intense. This seems like quite a heavy website, honestly. Documents. So we have this type here. So it's XHR, text plain, text HTML, JPEG document. I just want to get the document that was the home page. Wow. There it is. I don't know why I didn't show it before. If I look at the request headers section here, so these are the things that were sent to the server when I went to CNN.com. Google. So this is this is what I want to get back. The first thing I want to prioritize is I want to get part of this request. I can accept these types of encoding, like advanced. So this is the language I want to accept. So this is how this is sent by the browser by default, which is why you don't need HTML lang equals n. That's how items are cached. Here's the cookie information. A lot of cookies being stored here. Host, that's the host as a part of the request. Google.com. So this is the server as a part of the request when you click on a link, right? And this is the user agent, which you might see is Mozilla/5. Yourself, but this is Chrome, not Mozilla. A small glimpse into the crazy that is user agent. Back in the day, people started only delivering certain kinds of websites if they determined the user agent was capable of rendering those websites. Other browsers would say, like, I want to give me all that stuff too because it's cool, and so they started changing their user agent to make the server think that they had those features also. So fast forward like 15 years, and you get a jumbled mess, real consistent pattern to user. So this says Mozilla 5.0. So far, like this, I don't even understand. It's like this is. It says Chrome and Safari and Mozilla. So this apparently Chrome is just trying to. I don't even know anymore. I'm not up to date on my user agent strings recently, but it's jacked up to me. It's always been jacked up. This seems like incredibly jacked up. So, but you can see the refer is there. Actually introduced a typo, so I made it refer with 2 R's. If we use this refer back in our code, look at this request. Actually, let's look at the network tab and refresh. So we open up this guy. The refer is default because we didn't click on a thing to get here. We go then and we go to login. Right here back to localhost. Refer here was set to the home page because we redirected back to the home page. So I go to Alice Hello World homepage. If I click here, the refer was the homepage reply ID 0. Okay? For me. Okay. So if I add a message here, I post it, it gets added here. And there we go. I can reply to him. No one replied to him, so I'm going to post a message to his response, so on and so forth. Okay. Look at this like a tree, like if you were looking at like Reddit stores, it would be a giant tree of expandable text. But in this case, we're just navigating.
Your computer's on 7% battery.
Thanks. Actually, it went from 12 to 7 really quickly. So I should probably plug it in now. So at this point, this is actually a pretty. Oh, hey, look. They didn't take it. I just put it. Sorry, kids. Really. At this point, Inform Web is kind of a thing you could use, right? Like it's actually a thing that you could use to restore references to other people's threads and stuff like that. Right? It's pretty legit. I have food spooked, so I understand what you're doing too.
Nice. Yeah, tomorrow's lunch.
And do you mind going back to your code that you just changed for a second? The refer change? Yeah.
Yeah, what's up?
All of our Spark.posts should be in the main method, right?
Not the main method, in the main class.
Not in the main method, which means that we should have.
Oh, wait, I'm sorry. I totally misled you. You're exactly correct. My bad. Yeah, everything that happens here is inside the main method. You're totally right. Yeah, everything. So the last part here is just a part of the lesson is to learn how to build fat jars. We talked about fat jars before, and you can go over this and build it. I think right now what I want to do is let you guys take a quick break before we leave. I also need to update our assignment for the weekend. A few minutes.
Thursday. I'm like,
Yeah.
oh, you're uploading your code from today?
If you would like me to, yeah.
Is that what you